Hello everyone. Welcome back to another lecture on reasoning ability and problem solving. In today's lecture, we will discuss some practice questions on analogy. So let us start. Now, before we start discussing the questions, let us look at some important concepts that we will be using while solving questions on specifically on number analogy. The first concept is the difference between odd and even numbers. So we already know that odd numbers are those numbers that ends with that the last digit of those numbers ends with 0, 3, 5, 7 or 9. Similarly, even numbers ends with 0, 2, 4, 6 and 8. Correct? Then we should know what are prime numbers. Prime numbers are those numbers whose factors are 1 and the number itself. For example, if we have, let's say, a number 17. So 17 have two factors, 1 and 17. So 1 and the number itself. So you should remember prime numbers of at least 1 to 100. So if we start from 2, 3, 5, 7, 11, 13 up till 83, 89 and 97. These are your prime numbers that you should remember. In totality, there are 25 prime numbers between 1 and 100. So there are 25 prime numbers between 1 and 100. This you should know. Then you should learn the squares of at least 1 to 30. This many squares you should know. Similarly, you should know cubes of at least 1 to 20. This much information is very helpful to you for your competitive exams. So this much information you should retain. Then you should know what are perfect squares and perfect cube. So any number that has a perfect square root is called a perfect square. For example, a number, let's say 144 is a perfect square because under root of 144 will give me 12. Correct? Similarly, you should know what are perfect cubes. So any number whose under root of 3 will give me a number is a perfect cube. For example, if we have 1, 3, 3, 1. If we cube root this, we will get 11. If we cube root this, we will get 11. So you should know what are perfect squares and perfect cubes. There are two numbers. First number is 64 and the other number is 729. These two numbers are both perfect square and perfect cube. So these two numbers are both perfect squares and perfect cubes. So what do you mean by that? These two are both perfect squares, perfect cubes. Basically 64 is square of 8, correct? And it is the cube of 4, correct? Similarly 729 is 27 square, but it is also the cube of 9. So these two numbers 64 and 729 are special numbers because they are both perfect squares and perfect cubes. So this much information you should retain in order to solve analogy questions, specifically number analogy questions, in an efficient manner. So let us start with question number 1. Question number 1 is 2 and 10 and 30 and we have to find the missing term. So how do we proceed for questions on analogy? First step is to find the relationship between elements in pair 1. So the first thing is to find the relationship between the elements in pair 1. This is your pair 1. What is the second step in analogy? Second step is to use the same logic to find the missing element in pair 2. Correct? We use the same logic to find the missing element in pair 2. So this is how we solve questions on analogy. Let us look at this question. We have 2 and then 10. So the first logic can be plus 8. If I add 8 into 2, I will get 10. So if I add 8 into 30, I will get 38. But do we see 38 as an option? No. So this is not the logic that is being used. So now we will look at another logic. Another logic that I can see is if we multiply 2 and 5 together, we will get 10. So 2 multiplied by 5 will give me 10. Similarly, if I multiply 5 and 30, what will I get? I will get 150. So if I multiply 5 and 30, I will get 150. So this will be my answer. 150 will be my answer, which is given in option number 4. So option number 4 will be the answer to this question. Clear? Moving on to question number 2. Question number 2, we have 2, 7, 6 and we have to find the missing term. So first relation can be plus 5. So if I add 5, I will get 11. But do we have 11 as an option? No. So we have to look at another logic. How 2 and 7 are related. So if I see 2 and 7, if I see 2 square plus 3 can give me 7, because 4 plus 3 will give me 7. Correct? So, can I do the same logic over here? 6 square plus 3. What is the value of 6 square? 36. Plus 3 will give me 39. Do we have 39 as an option? Yes. So, 39 will be the answer to this question. Okay. Moving on to question number 3. Question number 3, we have 562, 30, 663 and we have to find the missing element. So first let us find the relationship between this number 562 and 30. So I can see it is a very big number and this is a very small number. So whenever I see such a change where a big number is changed into a small number, we assume that either we are multiplying or we are dividing. Correct? These are the operations that we look for. If there is a small change, it could be addition or subtraction. If there is a big change, it is multiplication or division. So if I see 462, I have to convert it into 30. So 5 into 6 into 2 divided by 2 will give me 30. How? 2 and 2 will cancel out. So 5 into 6 is 30. Now let us see if we can find the same logic for 663. So 6 into 3 divided by 2. How much will I get? This will be 3. Correct? 3 into 3 is 9 and 9 into 6 is 54. So I will get 54. Do we have 54 as an option? Yes. Option number 3 is 54. So this will be my answer. 54 will be my answer. Okay? Now, question number 4. We have 203 and we have to find. So simply I can say minus 2. Minus 2 if I do, I will get 1, which is not in the option. So this is not the logic. So let us look at another logic. Okay, let us look at another logic. Basically, if I do this number is 3 and all the options are 2-digit numbers. All the options are 2-digit numbers. That means it is at least being multiplied by 4 or 5 in fact, because 3 into 5 will give me somewhere 15. Right? It will give me somewhere around 15. So this operation, this is being multiplied at least 5 times. At least 5 times. So let us check. 2 and 0. If I look at 2 and 0, I can see that 2 square minus 8 or 2 cube minus 8. The value of 2 cube is 8. So 2 cube minus 8 is 0. So if this is a, I am assuming that a cube minus a cube is giving me 0. Sorry, a cube minus 8 is giving me 0. Now let us do the same thing for 3. 3 cube minus 8. What is the value of 3 cube? 27. 27 minus 8 will give me 21. So do we have 21 in the options? Yes. Option number 4 is 21. So this will be my answer. Okay. Question number 5, we have 6, 64, 11 and then we have to find the missing term. So 64 is basically what? 8 square. What is the relationship between 6 and 8? It is plus 2. Correct? So between 11 we will do plus 2, we will get 13. And what is the value of 13 square? It is 169. Is 169 in the option? Yes, it is in option number 3. So option number 3 will be the correct answer to this question. 169 will be the answer. Okay? Moving on to question number 6. We have 2264, 7241. So whenever we see big digits, we proceed by checking the difference or the sum. So if I check at the difference or the sum of the digits, it will be 7241 minus 2264. So if I see over here, this will be 3, this will be 11, this will be 7. This will be 0, sorry, this will be 1, this will be 13, this will be how much? This will be 7. And over here this will be 6, this will be 11, this will be 9 and this will be 4. So basically we are adding 4, 9, 7, 7. So if I add 4, 9, 7, 7 over here, I will get 6, 1 will be carried, 8 plus 2, 10, 1 will be carried. 9 plus 2, 11. 1 will be carried and I will get 8106. Do we see 8106 in the options? No. So this logic or difference of sum is not being used. So now let us look at another logic. So since it is a bigger number, let us look at the sum of the digits. So sum of the digits, 2 plus 2 plus 6 plus 4. How much will it give me? 6 plus 4, 10. 10 plus 2, 12. 12 plus 2, 14. For 7 to 4, 9. 7 plus 2 plus 4 plus 1. So 7 plus 2, 9. 9 plus 1, 10. 10 plus 4, 14. So basically the sum of the digits, this is also 14 and for it is also 14. Correct? Now let us check for 3 plus 1 plus 2 plus 9. So 9 plus 1 is 10. 10 plus 3 is 13. 13 plus 2 is 15. So we have to find a number whose sum is equal to 15. So let us check from here. 9 plus 5, 14. 14, or let me write it like this. 9 plus 5, 14. 14 plus 2, 16 plus 1, 17. So this is not the answer. Option number 3, 7 plus 1 plus 3 plus 2. So this is 8, 9, 10, 11, 12, 13. So this is sum is 13. So this is also not the answer. Option number 2, 2 plus 5 plus 7 plus 2. So 5 plus 2 is 7, 7 plus 7 is 14, 14 plus 2 is 16. So this is also not the answer. Checking for option number 1, we have 6 plus 3 plus 4 plus 2. So 6 plus 3 is 9, 9 plus 4 is 13 and 13 plus 2 is 15. So over here the sum is same, 15 and 15. So this will be the answer, which is option number 1, that is 6342. 6342 will be the answer. Okay. Question number 7. Question number 7. Again I see bigger digits. These are 3-digit numbers. So let me check the sum or the difference first. So between the first pair, 371 and 150, what is the difference? 1, 2, 2. So basically if I subtract 221 from 371, I will get 150. So now let us find the same logic with 468. So 468 minus 221. How much will it give me? 7, 4, 2. I will get 247. 247 is given in any option? Yes, it is given in option number 1. So option number 1 will be the correct answer to this question. Clear? Again, question number 8. We have bigger numbers. Okay, so let us check the difference and the sum. So between 423 and 657. So 657 and 423. I am finding the difference. This is 4, this is 3, this is 2. So basically we are adding 234 in the first element to get the next element. Right? We are adding 234 in the first element to get the next element. So we will do the same thing over here. We will add 234 in the first element to get the next element. So 534 plus 234 we will do. We will get 8, 6 and 7. So 768 is given in option. Yes, it is given in option number 3. So answer will be 768. It is given in option number 3. Okay. So option number 3 will be the correct answer to this question. Moving forward to question number 9. We have 365, 90. So now I see again big number and smaller number. So if I see big jumps between numbers, I assume it is a multiplication or a division. So if you see smaller changes, okay, if you see smaller changes, we assume that it is either addition or it is subtraction. Correct? And if you see bigger changes, we assume that it is either multiplication or division. Correct? We assume that it is either multiplication or division. So depending on the change, if you see bigger numbers, if you see very big numbers, okay, bigger numbers, this is valid for numbers which are equal to each other or unequal to each other. If you see very big numbers like 4-digit numbers, then we assume that it is either addition or subtraction. There is difference, or you can see it is there is difference between numbers. The logic is of difference, or it is sum of digits. Okay, it is sum of digits. So this should be basically the approach to number analogy. Approach to number analogy. So whenever you get questions on number analogy, you should follow this approach. Okay, you should follow this approach. Now coming back to question number 9. Question number 9, we have 365 and 90. So maybe certain operations are being done on 365 to get 90. If I multiply 3 into 6 into 5, how much will I get? 3 into 6 is 18, 18 into 5 is 90. Or 6 into 5 is 30, 30 into 3 is 90. So similarly, I can do the same thing for 623. 6 into 2 will give me 12. 12 into 3 will give me 36. So 36 will be the answer which is given in option number 1. So option number 1 will be the answer to this question. Clear? Now, moving on to question number 10. We have 20, 30 and we have to find out. So clearly this can be plus 10. And if this is plus 10, what will I get? 120? Do we have 120 as an option? No. So this is not the logic that is being used. So now let us look at another logic. If I say 20, 5 square minus 5 will be how much? 25 minus 5. Correct? It will give me 20. Similarly, 6 square minus 6 will be how much? 36 minus 6, it will give me 36. So it will give me 30. Correct? So this can be written as 5 square minus 5 and this can be written as 6 square minus 6. Correct? This can be written as 5 square minus 5. This can be written as 6 square minus 6. Now when I look at 110, what is the value of 11 square? 121. And if I subtract 11 from it, I will get 110, correct? So this can be written as 11 square minus 11. Now if you see the relationship between 5 and 6, this is basically plus 1. So over here also we will go plus 1. If I go plus 1, I will get 12 square minus 12. Correct? So 12 square minus 12 will be how much? 144 minus 12. So 4 minus 2, 2. 4 minus 1, 3. And 1 I will get. So answer will be 132. 132 is given in which option? Option number 4. So option number 4 will be the correct answer to this question. Clear? Option number 4 is the correct answer. Question number 11. We see bigger digits. Bigger digits, we try to find the difference. So between 245 and 121, I see a difference of how much? 124. Basically, I subtract 124 to get 121. So let us do the same thing for 357. If I subtract 121, I'll get 632. 236. Is 236 given in any option? No. So this is not the logic that is being used. So the first thing was to find the difference. If we do not get that, we will look at the sum of the digits. Now when I look at 121, one thing strikes me that it is 11 square. So if you remember squares, these things will be clearer to you because you can identify a number as a square. Let us revise these squares. Okay, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81 and 10 square is 100. Correct? Similarly, 11 square is 121, 12 square is 144, 13 square is 169, 14 square is 196, 15 square is 225, 16 square is 256, 17 square is 289, 18 square is how much? 324. Then 19 square is 361 and 20 square is 400. Similarly, 21 square is 441, 22 square is 484. Correct? 23 square 529, 24 square 576, 25 square 625, 26 square 676, 27 square is 729, 28 square is 784, 29 square is 841 and 30 square is 900. So these are your squares. So just by looking at this number 121, I can find out that this is a square of 11. Now if I sum these digits, 2 plus 4 plus 5, what will I get? 2 plus 4 is 6, 6 plus 5 is 11. So basically this is 11 square, correct? So here also I will find the sum, that is 3 plus 5 plus 7. How much will I get? 3 plus 5 is 8. 8 plus 7 is 15. So here I will get 15 square. And what is the value of 15 square? It is 225. So 225 should be my answer. Is this given in option? Yes, it is given in option number 1. So 225, option number 1 will be the answer to this question. Clear? Moving on to question number 12. We have 292, 146 and then 582. Correct? These are the numbers. Now, if you look at these numbers, 292 and 146. If I divide 292 by 2, how much will I get? 1. We will get 4. 1 will be carried. I will get 6. So, this is basically division by 2. So, we'll do the same thing in the second pair. We'll divide it by 2. So, 582 divided by 2. How much will I get? 2. 2 times will give me 4. 1 will be carried. 9 times will give me 18 and 1 time will give me 2. So, 291 will be the answer, which is given in option number 3. So, option number 3 will be the correct answer to this question. Clear? Moving on to question number 13, we have 123 and 36 and 125. So, similarly, I see big differences between these numbers. Differences between these numbers, so that means certain operations are being done here to get this number. So, when I see 36, clearly I can see this is 6 square. Clearly I can see this is 6 square. That is why it is important to learn squares, right? And if I find the sum of 1 plus 2 plus 3, how much will I get? 6. So, this is sum of digits of element A and square of that will give me element B. So, if I do 1 plus 2 plus 5, how much will I get? 1 plus 2 is 3, 3 plus 5 is 8. So, 8 square will be 64. This will be my answer, which is given in option number 3. So, option number 3 will be the correct answer to this question. Clear? Question number 14. We have 0, 4, 18 and we have to find the missing element. So, clearly I can see this is plus 4. So, if I add plus 4, what will I get? I will get 22. Do we have 22 as an option? Yes. So, this will be my answer. Option number 1, 22 is the correct answer to this question. Okay, coming to question number 15. Question number 15, again I can see big differences. So, let us, 121 is 11 square. Do you remember squares? Now, let us revise cubes also, okay? Cubes, 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube 125, 6 cube, how much? How much is 6 cube? 216. 7 cube is 343. 8 cube is how much? 8 cube is 512. 9 cube is 729. Then we have 10 cube, which is 1000. 11 cube is 1331. 12 cube is 1728. 13 cube is 2197. 14 cube is 2744. 15 cube is 3375. 16 cube is 4096. Then we have 17 cube, which is 4913. 18 cube, which is 5832. 19 cube, which is 6859. And then we have 20 cube, which is 8000. So these are your cubes. Now coming back to the question, this is 11 square. If I add 2 plus 4 plus 5, how much will I get? 2 plus 4, 6, 6 plus 5, 11. So basically the sum of digits of element A and square of that is giving me element B. So we'll do the same thing over here. 3 plus 5 plus 7. How much will I get? 5 and 3 are 8. 8 plus 7 is 15. So 15 square will be the answer, which is 225. So 225 will be the answer to this question, which is given in option number 2. Okay, option number 2 will be the correct answer to this question. So this concludes today's lecture. Thank you.